All right, so yes, we're going to learn about moles today and what they are and how to use them. This is Mr. Duncan. Hi, children. All right, so a mole. Anybody know who Avogadro is?
He's the guy that wrote the formula for the moles.
He's a guy, yeah. The guy, he's dead now, and he came up with a number. That's really all you need to know. What is his number?
6.02 × 10⁻²⁰.
This is Avogadro's number, and it is the definition of a mole. Okay? So if I have 6.02 times 10 to the 23rd M&Ms, I have a mole of M&Ms. If I have 6.02 times 10 to the 23rd pencils, I have a mole of pencils. If I have 6.02 times 10 to the 23rd students, I'm retiring, because that's too many students. But it would be a mole of students. Okay? So that's all we have to say. If I have 2 moles, it's going to be 2 times Avogadro's number. So it would be, what, 12.04 times 10 to the 23rd. That's really all we need to know about Avogadro's number. And from now on, we're just going to think, if I have a mole of something, we have Avogadro's number of something. It's the same thing as saying I have a dozen of something. Okay? That's the basics. Now let's apply it. So, if I have 1 mole of a substance, what does that mean? I have that many, well, whatever your discrete particle is, right? Not necessarily atoms. So let's choose hydrogen. Hydrogen is easy. If I have 1 mole of hydrogen, how many grams of hydrogen do I have? Now, in order to find this, it's actually very easy. We look at the periodic table. Pull up a periodic table. Come on. There it is. Okay. What's that number right below hydrogen?
1.008.
1.008, and that is called the atomic mass. So if we have 1 mole of hydrogen, I have 1.00, is it another 0? 2 zeros, 8. I have 1.008 grams. And if I get rid of all my other isotopes, if I have all just the regular isotope, 1 proton, 1 electron, it would be 1 gram. 1 mole is 1 gram for hydrogen. Let's do helium. Let's assume it's just the normal weight of helium, and we're not dealing with isotopes here. What would the atomic weight of helium be? Okay, so helium is going to have an atomic weight of 4, right? Yeah, 2 protons, 2 neutrons, so that's roughly 4. So 1 mole of helium is how many grams? 4. Cool. Is this easy so far? This should be really easy so far. Now we can start to make it more complicated, but it's not going to get too hard. If I have 4.2 moles of oxygen. Actually, oxygen is a bad example for reasons we'll get into later. Iron. 4.2 moles of iron. What is the atomic weight of iron? 55.845. So If I have 4.2 moles of iron, how many grams is that? What's the equation that we're going to use there? Multiplied by. Yeah, this is not too hard, okay? The units of that atomic weight are grams per mole. So what cancels? The 2 moles cancel, and we are left with, can you calculate this real fast? It'll be something like 220. 234.549. And my units are grams, right? Easy. So when we have a number of moles, we can very quickly and easily convert to mass for a substance. When it's just a single element, that's the easiest case possible. But it's not always going to be that easy. Let's look at if I have 102 times 10 to the 20th atoms of copper. How many grams do I have? So what's the first step here? Not atoms into grams. That's eventually. We'll get to grams. Atoms into moles. All right. So we have 102 times 10 to the 20th atoms. What's our conversion factor between, thank you, what's our conversion factor between atoms and moles? How many atoms are in a mole? How many things are in a mole? 6.02 times 10 to the 23rd. And what are the units here? Is it moles per thing or things per mole? Things per mole. In this case, what is our thing? Okay, so atom per mole. Do I want to multiply or divide here for my atoms to cancel? Divide, absolutely. So we will divide here. That makes my atoms and my atoms cancel. What does this equal? It's going to be a very, very tiny number. 1.69 times 10 to the oh, you have to put parentheses around 6.02 times 10 to the 23rd.
That's really dumb.
Yeah, this is not a smart calculator. Here, easier.
Okay.
Just use the Google search bar to do it. So I put parentheses 102 times 10 to the 20th. Then I end my parentheses over parentheses 6.02 times 10 to the 23rd, end my parentheses, so the top and the bottom are both in parentheses. And then I hit enter, and Google tells me that it is 0.01. 69. And what are my units here? Moles. Good. Are we done? No, we want to know how many grams of copper we have. So what would our conversion between moles and grams be? The atomic weight. So the atomic weight of copper is what? It's in there, I promise.
Okay, that makes sense.
All right, so we will now take 0.0169 moles of copper, and we're going to multiply by 63.546 grams per mole. And what would that be? .07-ish grams of copper. So that is how we convert from a number of atoms of things to grams. You may be asked to convert from atoms, or as we get more complicated, molecules into grams. But it's not too hard. You just have to keep in mind, what do I want to cancel? Oh, I want atoms to cancel. Atoms are here, so I have to do that divide, okay? That's really the tricky part, is keeping your units on the correct side of the fractions. So we can now do atoms or particles to moles and moles to grams for anything. If I were to give you the atomic weight of, let's do a really bizarre case. Name something crazy. Anything in the universe that's crazy.
Like an object or
An object, like friendship. Let's do friendship, okay? Friendship is crazy. I have, what's a friendly number? 3. I have 3 moles of friendship. Okay? How many grams of friendship do I have? So what do we need to know? We need to know the atomic weight of friendship. And I'm going to tell you that friendship, which is going to have the chemical symbol of a heart, has the atomic weight of 100. So how many grams of friendship do I have? Well, let's do the math. 3 moles times 100 grams per mole equals 300 grams of friendship. Okay? That's silly, right? But if you can do this, then you understand it. Right. Now it gets tricky, because we're no longer going to be talking about individual atoms. We're going to start talking about multiple atoms in the same thing. Now, this is like if I have a couple pieces of Legos, right? And I put 3 Lego pieces together. What's the mass of that one piece? It's the mass of the 3 added together, right? So if I'm finding the atomic weight of that piece, I'm going to have to know the weights of each individual piece. So let's start with a really, really simple one. This is the one I didn't want to do earlier, and you'll see why now. Diatomic oxygen. Now, let's look on the periodic table. What is the atomic mass of oxygen? Yeah, we're going to say 16. So oxygen has a mass of 16, an atomic mass of 16. How many oxygens do we have here? 2. So the atomic mass of diatomic oxygen is 32 units. Yeah, grams per mole. Because we have that 2 here, we have to multiply by 2 to get 32. So if I have 2.4 moles of diatomic oxygen gas, how many grams do I have? What's the equation? What am I going to do here? What cancels? Moles cancel. I wind up with 2.4 times 32 equals 76.8 units. Grams. And then what am I dealing with here? Diatomic oxygen, yeah. So that's how we solve it in this very basic multi-atom case. You want to get slightly more complicated? Of course. All right. Yeah, everyone loves water. So 6 moles of H2O. What do I need to find? I need to find the atomic mass of water, right? Which is going to be atomic mass of H2O equals atomic mass of hydrogen plus atomic mass of hydrogen plus atomic mass of oxygen. Hydrogen is 1 plus 1 plus 16. So that equals 18 units are still grams per mole. All right, so I have 6 mole. What do? Multiply by 18 grams per mole. What cancels? Moles cancel. I get cool. Easy, right? Do not forget to do this for whatever molecule you're doing, okay? If you do this part correctly, this part is super easy, right? Can we go backwards? Yeah, let's go backwards. So this is really making our lives a lot harder, but we need to be able to go forwards and backwards through this process. I have 100 grams of, what's your favorite molecule right now? That's an atom. Molecule. I need
Like a polyatomic ion?
polyatomic anything.
Sulfate.
Sulfate. That's SO4, right?
Yeah.
Okay. It has a 2 minus up here, but I don't care. Okay. Not for these calculations. Because electrons weigh exactly what? Nothing. Electrons weigh so little that it does not impact these calculations whatsoever. You could have 1 million electrons added into your atom, and first off, it would explode, but secondly, it wouldn't affect the weight at all. So if I have 100 grams of sulfate, how many moles do I have? So, first off, what do I need to know? Before I freak out about any of this, what do I need to know? What's the mass? What's the mass of sulfate? So how do we do that? It's going to be a sulfur, which is 32 plus 4 O's.
Oh, that's 64.
64? Are you sure?
Yeah.
Plus 32?
Is 96.
We're going to go with 96.
Let's hope he's right.
What are my units?
Um,
Yeah, grams per mole. So if I have sulfate, it's always going to be 96 grams per mole. Now, I want to go from what to what? From grams to moles. So I'm going to write down what I have, 100 grams. Now I'm going to leave this operator blank. Okay? What's my conversion factor? Yeah. 96 units of grams per mole. Now, do I want to multiply or divide here to get my grams to cancel? Divide. So I'm going to divide, grams and grams cancel. I wind up with slightly more than 1. 1.04. What are my units? Moles, because the mole is going to flip up to the top when you divide. So I have 1.04 moles of sulfate. Cool. That's how you do it backwards.
So where does the 6.02 come in?
The 6.02 times 10 to the 23rd only comes in when you're converting from one of a thing to a mole of a thing. You may be asked to do that like once or twice, especially on a quiz, like your next quiz, or a test. However, in the real world, nobody cares because we literally never deal with one thing. We're talking, I mean, this thing is so tiny that it takes, it's going to take, what, 0.1 mole, which is a heck of a lot of things. We're talking about 10 to the 22nd things, right? Just to make it 10 grams, which is a minuscule amount. So let's never deal with individual atoms or molecules ever. Let's only deal with things we can relate to, which is a mole. Now, moles will allow you to calculate all of the numbers in a chemical equation. We're not going to do that now, but that's the next step. Once you're solid on this, once you've done a bunch of practice problems, so you can go forwards from moles to grams, and you can go from grams to moles. Once this is super solid, then we can move on to switching outside of just the sulfate. Because in the future, we'll be able to use what we know about the sulfate to calculate the other chemicals in the equation. Got it? No, it sounds tricky. It isn't. It's just doing 4 things in a row rather than doing one thing. All right, got it? High five.